problems and problems that actually, affect your, your community. So that's why I think, one should, care about mobile development. Cool. Okay, so just going back in time, before everything, before we, I don't even know how to put it, like before we even had like smartphones, let's just go back there, the time when the iPhone was introduced. So on the 29th of June, 2007, Apple released a new mobile device, namely the iPhone. So the iPhone was introduced as a breakthrough, smartphone that was truly smart, it was easy to use, and it ran the same operating system as their Mac devices, which is, Mac OS X. And because of that, existing Mac OS X applications could be ported to, could easily be ported to the iPhone. So developers could write applications for the phone using Objective-C, like the Objective-C programming language. And, time went, more and more developers got interested. And then, as time went by, Apple rather, released their App Store on the 10th of July, 2007. All right, cool. So time went, and on the 23rd of September, 2008, just 6 days before my birthday, actually, Google released their own operating system. So it was based on a modified version of the Linux kernel, and they called it Android. All right, so that's Android as we know it today. So Android was open source, it was free, and which basically allowed manufacturers to kind of modify it however they wanted, and sell phones or smartphones based on Android without having to pay royalties to Google. Or I think the contract was that if you build mobile phones that run on Android, you have to, the phones themselves had to have Google services installed. Otherwise, the operating system itself was free and open source, so everyone could or anyone could just use it for their smartphones, basically. All right, so if we fast forward to 2010, I see it's not on the chart here, I mean. So if you fast forward to 2010, smartphone sales were rather booming. So about 297 million smartphones were sold just in 2010 alone. And end users wanted more applications, they wanted more features, and an increasing number of companies were now moving, some of their services to mobile phones. So the mobile app industry itself was getting rather big. More people wanted, or more developers were needed to build apps, and the apps that they were already building were getting more and more complicated. But the problem was that around that time, so you now had two platforms, Android and iOS, and developers wanted to run their applications on both platforms, but were having a hard time, maintaining two separate code bases, basically for the same application. Because the first one for iOS is in Objective-C, so the application had to be written in Objective-C. And then for Android, you had to write your application using Java, using the Android SDK. Now, it got really hard for developers to maintain two code bases for basically the same applications. So time went, and more people got interested in this thing of writing your code once and having it run on both platforms. So in 2013, the Xamarin company released Xamarin 2.0. So that basically used C#, and it allowed programmers to write. So basically, you could write your app in C# and it will run on both Android and iOS. So so that was Xamarin, basically. Now, the thing with Xamarin, however, was that it, how can I put it? Even though your app was written in C#, you still had to write some platform-specific code. And, and the resulting applications are rather big, especially for Android. It costs a lot of data to download the applications built with Xamarin. And also, the user interface for Xamarin apps required kind of a lot of work to get it to look similar, or look the same rather, on both platforms, like both Android and iOS. you needed to do a lot of styling to get, for example, your buttons to kind of like look the same on both platforms. So, okay, so someone is saying, hello, everyone. Hello, Kevin. Cool. So on the 26th of March, 2015, so just 2 years after Xamarin. Yeah. So 2013 Xamarin, 2015, yeah. So 2015, Facebook released their first version of React Native. So React Native basically allowed developers to build Android and iOS applications using JavaScript. All right. So, and because so many people or developers rather knew JavaScript, the framework itself was adopted rather quickly. But its main disadvantage was that it bundled a JavaScript interpreter with your application, which meant that it had that extra code that made your application big, and also the fact that it's running an interpreter. Your application was slow, when running on a mobile device because it's running an interpreter. I don't know why my head is tilted. Anyway, so yeah, so that was the problem with React. So 2 years later, Google entered the scene and they were like, okay, guys, we introduce to you the Flutter framework. So in 2017, the Google team released Flutter, like the first version of Flutter, which is kind of like alpha, as they called it. And so, yeah, so basically Flutter is what we're going to be, using in all the workshops that we'll be having for mobile. So yeah, I'm going to explain Flutter now. So cool. All right, so the team behind Flutter describes it as like, they describe it using 4 tenets. So that's basically kind of like principles or whatever. The first one is basically beautiful, like Flutter is beautiful, or Flutter apps are beautiful. 2, Flutter is productive, and Flutter is fast, and lastly, Flutter is open. So by beautiful, they meant that unlike React and Xamarin, or they didn't specifically say unlike React and Xamarin, but you can just work it out. So unlike React and Xamarin, Flutter paints its own user interface. So that basically means that when you run your Flutter application, the app itself will request a canvas from the operating system, kind of like a big screen and it uses that that canvas to draw its own user interface. So how's it different is that with Xamarin and React, the Xamarin and React apps will call the operating system to basically draw the user interface for them. So let's say, for example, your React app had a button. It will call, the iOS framework on iOS to request that, it draws a button. And then on Android, it will call the Android framework to draw that button. Now, this comes back to the fact, to what I said earlier, that, the button that iOS was drawing was not the same to the button that Android was drawing, right? So it required a lot of work from the developer side to get those two buttons to be the same. So with Flutter, it goes a little bit differently because you have the application itself is drawing its own buttons. It's drawing its own user interface. It does not rely on the operating system to draw those things for it. So yeah, so that's where Flutter, the beautiful part comes in. And then secondly, they said Flutter is fast. Okay, let's go to fast and then you can go to productive, just going like this. So they said that Flutter is fast. So what they meant by that was that, first of all, Flutter uses the Dart programming language, which is what we're going to be covering, in this workshop. So Dart is a programming language that compiles directly to machine code. It can be interpreted, but it can also compile to machine code. In fact, all Flutter apps are compiled to machine code. So, and because of that, they run really, really fast. Because if you compare to React, for example, in React, your JavaScript code is getting interpreted. But now with Flutter, it's compiled directly to machine code. So that makes it really fast. And then thirdly, they said that Flutter is productive. So what that basically means is that, okay, the productive part has to do with the fact that Dart code can be hot reloaded. So what that means is that you will write your program and you will run it on a device. And while that program is running, you are able to make changes to your code, and your code and the changes you make will be reflected on that running application. So you don't have to write your code, run your application, and then stop your application to make changes and then run it again. You can make changes to a running application. So that's where the productive part comes in. Flutter is productive because Dart has hot reloading. And the last tenet was that Flutter is open. So it's open in 3 ways. The first one is it's open because it's open source. And 2, it's open because it's free. Like anyone can use Flutter. Yeah, you don't have to pay anything. And lastly, it's open because it's customizable. So what that basically means is that, it goes back to the beautiful part where that Flutter paints its own user interface. So it's open because it's customizable because you can draw your own user interface as well. Let's say you're not happy with the way Flutter is drawing its buttons. You can decide to draw your own buttons. That's where, the customizable part comes in. So yeah, that is basically Flutter. And yeah, so for the remainder of this, workshop, we will be learning about Dart, as a programming language. And yeah, it will be kind of like hands-on. So we will be writing code basically. There's no slides for the next part. So cool. Yeah, so based on what I've said or what I've presented to you guys, like now, is there like any questions? Oh, by the way, I see that your mics are not enabled. Yeah, does anyone have like a question or anything, they're not clear about or they want to add? Yeah. Okay. Okay, cool. All right, cool. Now we're going to look at Dart, like Dart as, as a programming language. So, okay, how Dart is described, by the team from Google is that, first of all, it is optimized for user interfaces. So that basically means the syntax or the way you write Dart code or the rules around it, rather, I don't know. Yeah, but the syntax for Dart is more optimized for describing user interfaces. I saw in the RSVP thingy that some people said they worked with Android and Xamarin. Yeah. So basically, if you're familiar with Android, you know that you will have an XML file, and that's where you basically define your user interface. And then you have your Java code, which is basically where your business logic is going to come. Now with Dart, you basically have XML and Java in like one programming language. I don't know if yeah, I don't know if that makes sense, but that's basically how it is. It's optimized for user interfaces. So it's a programming language that can also describe things that you can use to describe things like, user interfaces and stuff. And secondly, it's productive. It allows for productive development. So that goes back to the hot reloading thingy, which is basically, yeah, you write your program, it runs on a device, and then you push changes to that running program without having to stop that program. And lastly, Dart runs on all platforms. So by all platforms, we mean Android, iOS, Mac, Windows, Linux, and the web. Yeah, so it can be compiled to like machine code. Machine code can be interpreted, and it can also be compiled to JavaScript. So yeah, that's basically Dart. All right, cool. I guess now this is kind of like the part where we're going to Dart itself. Like, I'm trying to see if I can enable your microphones here. Just if you ever, because the next part is going to be more like hands-on. So, if you want to say anything, just okay. Okay, I don't see that setting. All right, if you have a question, just drop it in the chats. I guess I'm gonna speaking alone. I didn't want that, but yeah, but I don't see any setting to change the stuff. Yeah. I see set as host, presenter, blob chat. Okay. Yeah. If there's anything that you like, you have a question, just drop it in there. And I'll answer for you. Cool. So if you have your laptop, just open dartpad.dev. So that's basically this this website here, dartpad.dev. Yeah, just open that. All right, cool. So, okay, what I wanted was that we first go over the structure of a Dart project, but what I'm worried about, or what I was worried about rather, was that not everyone will have installed, the VS Code, the Flutter SDK things. So what I decided is that we're gonna go with Dartpad just to, explore Dart itself as a programming language. And then, when we get to the Flutter workshops, we will go into, the structure of a project, like packages and everything. So right now, or for this workshop rather, we're just gonna learn about Dart, its syntax, the things that you can do with it as a programming language. Yeah. Okay, cool. Obviously, the first thing that you write for any language is like the hello world program, the hello world program. So that basically means that printing hello world to the screen. So if you look at this, you will realize that it's similar to C and Java. Now, remember what I said, that Android is from Google, right? And Android apps are written using XML and Java, right? Now came Flutter, and we can assume, or not really assume, but we can see that Dart is influenced by both XML, not really both, not really that much by XML, by a lot by Java, but by a lot by Java. So yeah, so Dart code looks more like Java code, right? Except for the fact that you don't have to wrap your main function inside a class. You can just like C, you can just put it outside the class. So yeah, so the main function basically returns void. That means it returns nothing, and then you have main, obviously, and then you have the parentheses, and you will have the braces to kind of like put your blocks together. So yeah, that's the main function. And then the comment here is what we call a documentation comment. So if you're using VS Code, when you hover above this main function, you're going to see print hello world on the screen. It's like the documentation for the main function rather. And yeah, so that's the documentation comment. And you also get the other comments, the other two types of comments. This is a line comment. So just like Java, Java has this comment. We put two slashes and then you write your comment, and then you also have like block comments, which basically, or multi-line comments rather, which basically multi-line. Yeah, so that's a hello world program. Okay, just to remind you guys, because it feels like I'm talking a lot. Sorry for that. If you get lost in anything, just let me know. So yeah, just let me know if you get lost in anything. So that's basically the hello world program, and if we run it, it's supposed to print hello world. There we go. All right, cool. Another thing I wanted to show you is that in Java, you will have import something dot something dot something to import, or to use another package, or to use another library. So in Dart, you have something similar, but your import comes inside a string. Okay, that's interesting. If you would like to speak, switch to presenter mode and unmute your mic. Someone wants to try that. Just want to see if that's how you do it. Okay, yeah. If you want to speak, just put yourself in presenter mode and unmute your mic. Okay, cool. So coming back to the import thingy, for example, let's say you want to import the math library. So the math library is part of Dart itself. It's not a package we install, let's say, from GitHub or from dart.dev or pub.dev rather. So how we import the math library is basically Dart, and then we have math. So that's basically how you import a library. Now, let's say, for example, we want to print pi, which is defined inside the math library. You just have to do pi. So that's the first way of importing things. But you can also have an import alias. Yeah, import alias. So that comes a semicolon there. So an import alias is basically something like this. So you import your math library, but as something. So as math. So import dot math as math. Java has this, but yeah, that's another feature when it comes to importing stuff in Dart. So the idea of this is that let's say you have you importing two packages, and they define the same variable or the same function or the same class. So if you use import as, you can be able to avoid that those two variables or classes being clashing basically. So yeah, so one of those classes you will import it as something else, and then you can import the other one like normally, or you can also import it as something else, and yeah, just to avoid that clashing. So that's where this as thingy comes in. So print math.py. So basically we're printing pi, which is defined in the library or math, yeah, which is defined in the math library. So that's the hello world thingy. So if you run this, it's supposed to print hello world and 3.14159, which is the pi thing. Yeah. So yeah, that's basically the structure of your main Dart program. Now, what I want to go through is the data types. So I'm just going to copy this here. Okay, cool. So what I want to go through is the data types. These are just warnings. We can ignore that. So again, we have our main function, which is our entry point, basically. And then, okay, we're defining a lot of variables here. There are like kind of like three ways to define variables in Dart. So the first one, let me see, 1, 2, 3, actually 4 ways. Okay, yeah. So the first one is where you have the data type, and then you have the name of the variable, and then you have the equal or the assign. The equals operator is equal to, then you have the value of the value you want to assign the variable to. Yeah, on the right you have the value. So it's the data type, the variable name, and then the operator equal, and then you have the value on the right. So that's the first way of defining it. And I think this way is the same as in Java. The data type, and then comes the variable name, and then this thing here, and then the value on the right. The other way is when you don't specify the data type, but you let the compiler infer it for you. So for example, we're saying here variable b is equal to 5. So the compiler will basically say that, or will basically know that variable b is an integer, because like 5 is an integer. So it will infer that b is an integer. So if we have to say, for example, b is equal to 5.0, then it will infer that b is a double, like a double precision floating point value. So that's the second way, and I think this is the most common, or this is the way that you will see, as you go through Flutter or Dart code, you will see this more often. Yeah, this or the final one. So yeah, this one is more, okay, the first one is more like Java. Just gonna see if we can maybe. Then the second one is more like JavaScript. This one is more like JavaScript. And then here we have final. So the final is basically works the same way as in Java, where if you define a variable as final, you can never change it later. So us saying here that d is equal to, or c is equal to 5 and is final, we're basically telling the compiler that c, first of all, it will infer that c is an integer, and then secondly, it's gonna put kind of like some rules around c, that c is a final variable and c cannot be modified or assigned to anything else because it's a final variable. So this one is also similar to Java, except that in Java, you will have to add the data type just after final. So yeah, let's just leave this. So that's final, right? And then the last one is dynamic. So dynamic is the same as the first one, but the data type this time is dynamic. So what that basically means is that we want to assign any data type to D. So we say D is equal to 5 here. So the compiler is going to infer that D is an integer. So because it's dynamic, we can later say, for example, D is equal to 6.0. And it will still be happy because D is dynamic. So we can assign anything to B, any data type we can assign to D rather. Okay, and then we get nullable types. So Dart is kind of like Swift or Kotlin. It has null safety rather. So what that basically means is that you, the developer, have to specify or tell the compiler that you expect a certain variable to take null. All right. So how you do that, you basically put this question mark just after the type. So we're saying, yeah, E is an integer and it's equal to 5, but we are okay for it to be assigned null. All right. So its value can be null. That's what this basically means. This question mark thing here. All right, cool. And then you get integer types, double types, and then the number types. The number types, you basically have num. Let's say my number. So int is for integers, double is for double values, and num is for both integers and double values. So my number can be 4. In this case, it will be, so in this case, we're taking 4, the integer, and we're assigning it to my number. And we can also say my number is equal to a double, let's say 5.6 or 5.6. So yeah, num is for both integers and double, basically for numbers, and integers and doubles are numbers. And then you get Boolean types. So that's your true and false. I think in Python, you will have the capital letter true and the capital letter false. In Dart, you have Dart, yeah, basically again, just like Java, you have the small letter true and the small letter false. So H here is equal to true. We can also say H is equal to false. So yeah, in that case, H will be false. And then you get strings. Okay, strings work the same way. Not really the same, but it's kind of like similar to Java. So we're saying here our variable str is a string and it contains the value learning dot, and then we have that thing in there. And then here, this is where a nice feature comes in. They call it string interpolation. So what this basically means is that you can insert one string into another string. All right. So here we're building a string. Just here, we're building a string, and this string is we are. And then at this point, just here, we're inserting the value of str. So this is supposed to print we are, and then the value of str learning dot. So we are learning dot. So yeah, let's just print that and see what happens. There we go. We are learning. Okay, we are learning dot. So that's the string interpolation thingy. Cool. So that's variables and types, like the basic ones. What I'm going to go through now is the list and maps. So list, okay, cool. So again, we have our main function, and yeah, we have a main function, then we have our body. So lists are, I wouldn't say are the same as in Java, but they kind of like, okay, yeah, Dart is kind of like different, yeah. Okay, so again, we have a variable, and we call it my list, and then it contains these elements 1, 2, and 3. All right, and then here we print the list. Let me actually print it. So here we print the list. Oh no, we don't print the list. We print the first element of the list. Okay, so this is how you access elements inside a list. You use, just like in Java, you use these square brackets, and then you put the index inside. And yeah, that's basically how you index a list basically. So here we're printing the first element of that list, and that is 1. Yeah, because it's this 1 here. And then here we changing the value of the second element of the list. So my list 1. So my list 1 is the second index. So the index of 1 is the second element, I mean. And we assign that to the value 5. So when you print it out, we see that the second element is 5. And then here, we pushing a new element into the list. So we had 1, okay, we had 1, 5, and 3. And now we're pushing a 4. And then this is how you basically like iterate through or rather print every element in the list. So you basically, this is what you call a for each loop. So that basically saying that, this is basically saying that for each item in my list, we want to print that item. Obviously you can do anything you want here with the item, but in this case, we're just printing the item. So for each item in my list, we want to print the item. So yeah, that's basically what we're getting here. So the 1, the 5, the 3, and the 4. So remember we had 1, 5, 3, which we got here, right? Because we set the second element to 5. So we got 1, 5, 3. And then we added a 4 right at the end. So that's 1, 5, 3, 4. All right, cool. And then I want to show you mapping a list. So this is what you're gonna be doing this a lot, especially in your Flutter code. So mapping a list is basically, let's say you have a list of integers and you want to convert that to a list of doubles. So mapping is basically you running through the list and converting it to a list where each item is basically transformed to something else. So here we are doubling each item. Okay, so we're saying var double list. So this is the list that's going to contain our second list, the one that's containing the items that are being doubled, basically the doubled items. And then this is obviously the first list, and then we map it, and then we take each item, we say item multiply by 2. So this is a closure. Yeah, this is what they call a closure. But I think in what do you call it? Java, they call lambdas. All right. So you're basically passing a function to another function. Yeah. So that's what you're basically doing here. This is a function, item, and then this fat, what they call it? This arrow here, and item times 2. So this is defining a lambda, and that's the lambda we're passing to the map function for that list. So it basically takes each item and then it doubles it, multiply by 2. And then here we convert the result back to a list. So map returns a data structure that is similar to a list. It's called an iterable. That it returns that, but it's not really a list. So basically saying to list is us converting that iterable back to a list, which we then store into the double list variable. So yeah, you'll be doing this quite a lot in your Flutter code. So for example, if you pull from a database a collection of, let's say, contacts. Let's say you made like a phone application and you're pulling a collection of contacts and you want to display that. So you're basically going to run through those contacts items and then convert those item or context items to views or widgets. Yeah, but we're going to see that like when we go through Flutter again, when you go through Flutter. Okay, I should share the source code when I'm done. I will do that. Yes, in fact, let me see if I have anything. Yeah, I will share the source code when I'm done, definitely. And then does the map function work the same way as we? Yes, that's actually a nice observation there. The map function works the same way as in JavaScript, where you basically say map and then you pass in a function that takes an item in the original list and then does something with that item and then it returns it to what do you call it? To the map function basically. So I think in JavaScript you will do something in these lines. like I know JavaScript also has this arrow function here, or this arrow operator, but you also can do something like this, just to show that it's a function. So you define a function like an anonymous function, and then that function returns the transformation, or does the transformation basically for that item. So this is supposed to print the same thing. Yeah, it prints the same thing. Yeah, so this map function works the same way as in JavaScript. So yeah, great observation there. Okay, cool. So those are lists. We're now gonna check maps. So in Python, you have something called a dictionary, right? In Dart, you have maps. It's the same thing, just a different name. Dictionary in Python, and you have a map in Dart. So here okay, I don't know why I said list. So this is basically a map. So this is a map. So here we're defining a map, my map, and so basically this is a map it maps a person's name to their surname, all right? So Steve is mapped to Jobs, and Bob is matched to Mali. So Steve matched to Jobs, and Bob is mapped to Mali. Let me see if I format it. Okay, same thing. Oh, by the way, this format feature here, basically formats your code so that it looks a little bit nicer. For example, if we have this extra space here and you say format, it's going to put it back together so that it looks a little bit neater, if you can call it that. So when you do check this out, do format your code, especially if you want to share it. Okay, cool. So coming back to the my map thingy. So this is our map. We're mapping Steve to Jobs. We're also mapping Bob to Mali. And then we print the value that Steve is mapped to, all right? The value Steve is mapped to, and that, okay, let's just run it. And that is Jobs, right? So print my map where the key is Steve. If you think in terms of dictionary, you have the key and you have the value. So the keys here are Steve and Bob, and the values are Jobs and Mali. So the key Steve is mapped to Jobs, to the value Jobs, and the key Bob is mapped to the value Mali, right? Now here, when you say my map, and then you put the square brackets, and then we say we want Steve, or the value of the key Steve, we're supposed to get Jobs, which is what we get back here. So this is how you define a map. I think you use the same, use kind of like braces, just like in Python. So yeah, that's how you define a map, and that's how you read the value of a certain key. And then here we are changing the value of the key Steve. We're changing the value of the key Steve. So remember, Steve, the value of Steve was Jobs, but now here we're changing the value of Steve to Harvey. So yeah, the value of Steve to Harvey. So when you say print my map again, the value of Steve is supposed to be Harvey now. So if we check here, we see Steve is now mapped to Harvey and Bob is mapped to Mali. Okay, so that's how you change the value of an existing key. Now, if your key does not exist in the list, how you can add it to the list is that you will use put if absent. So my map put if absent. So there's a method called put if absent. So if your what do you call this? If your key does not exist in the list, you will then in the map you will use put if absent. So here we're putting Michael. If Michael is absent, then we want to map Michael to Jackson. So again, here we see a lambda function, or a closure, a lambda. Yeah, let's just call it lambda. So what this is saying, so this function is basically returning a string, Jackson, the string Jackson. So put if absent will check if Michael, or the key Michael, exists in the list. And if it doesn't, it will add the value, it will add it to the list and set its value to Jackson. So that's what this lambda here returns, okay? And then here we're just running through the list. So we're saying, again, we have, okay, I don't know what I did there. Again, we have a for each loop. So for each key in all the keys in the map. So for each key in my map, .keys. So .keys again is an iterable of strings. And yeah, so when we run through that iterable, we get the keys. So what we're basically doing here, again, we see string interpolation. We're printing the key, and then we add the text has value, and then we're printing the value of that key. Time seems to be moving fast, eh? And then we add the value of that key. So what this is supposed to print, Steve has the value Harvey. Again, it's printing this list, and Bob has the value Mali, and then the one we just added here, put if absent, Michael has the value Jackson. So yeah, those you know, the data types you'll be using a lot in Dart. Yeah, so those are like the basic data types in the list and the maps. So if there's any questions on that, please do drop them here. I actually wanted us to do an exercise because I prepared some like 2 exercises on this, and time seems to be moving really, really fast. Yo, can I get an indication who's keen on doing the exercises? Just drop something on the chat. Okay, I see 2 people saying they're good. There's like 14 people in here. Okay, there's still 2. Okay. How do we drop an item? Interesting. Okay. How do we drop in this map or in the list? Can you just indicate in there? Because I think you drop them differently. Okay, I'm just gonna assume you mean the map, on the map, okay. So on the map, interesting. I think in Python you will do delete map, and then you have your, you know, your key here. In Dart, there's supposed to be a function. Let's say we want to drop, let me just go to the end. Let's say we want to drop, let's remove Bob. So if I say my map dot, okay, now this editor has a nice feature. You can see all the methods in the, what do you call this, in the map. So there's supposed to be a remove. There we go. There's a remove method which allows you to drop a specific key. You can also drop keys or entries that pass the given test. So you can pass a test and you can drop those keys. Okay, I'm just going to show you. Let's say we want to remove Bob. I will say my map.remove Bob, and then let's print our map now. .remove Bob, and then I run. Let's see what we get there. Okay, there we go. So Bob has been removed. So Steve is now mapped to Harvey, and Michael is mapped to Jackson. So Bob no longer exists. So that's basically how you can drop them. Okay, coming back to the exercises thingy, I see that only 3 people said yeah. Okay, so out of the 13 people, I assume that, you know, time is going fast. So what I can do, I'm just going to share. I'm going to share my notes with you all, and then you know, you can complete the exercises like yourself. You know, when you get a chance, and then, you know, if you run through, you know, any issues, you just pop them in the club WhatsApp group. Cool. So those are maps and lists and the basic data types. So what you're going to be going through now is functions and closures again, because you're going to be passing functions to other functions a lot, especially when you're writing your Flutter code, because Flutter is basically, yeah, you know, you're passing data around and functions are going to be part of that data. So yeah, we're just going to be covering functions and closures here. Okay, cool. So this is a simple function. Again, it's exactly the same as you would do in Java, except that in Java, obviously, you will have a class, and then inside the class, you will have your method, which is the function. So here, like, remember that your functions can exist outside of classes. That's like, when it comes to that part, that, you know, functions can exist outside of classes, that is more similar to C and C++. Python also, yeah, but the syntax is different. Yeah, so functions can exist outside classes, and this is how a function looks in Dart. So again, you have your return type. You will then have the name of your function, and then you have the the parenthesis, which is basically where you can put your parameters or your arguments rather, I don't know. And then you have your braces, and then you have the body of the braces are basically the body of the function itself. So here we're defining a function called getPy, and it returns the value 3,14159, all right? And then you have arrow functions. Now, arrow functions are basically functions. So let's say, for example, you have a function. Okay, let me put it like this. So functions can be like one line, or they can be multiple lines. So if your function is multiple lines, then you will use the braces. Like you put your body inside the braces. But if your function is like one line, then you can just use an arrow function, just like in JavaScript. If your function is just one line, you can use an arrow. You can use the arrow and then put that line here. And also the value. So okay, so how an arrow function is like described, you will have your return type, then you have the name of the arrow function, and then you will have the parentheses, then you have the arrow itself, and then here you have the expression. So this expression can be void. Basically, it can be like an expression that returns nothing, or it can be an expression that does evaluate to something. In this case, getPy evaluates to the return value of our getPy function. So in this case, when you say arrow getPy, the value of getPy will be the return value of our arrow function. So yeah, that's again, it's just like in JavaScript. If you've checked JavaScript, I saw in the RSVP thingy that a lot of people do know JavaScript. So yeah, just like in JavaScript here. And then here you have a function with positional parameters. Okay, so there's two types of parameters in Dart. You will have the positional ones, and then you have the name parameters. So the positional ones are like, just like in Java. They just like in Java, you have your return type. Obviously, we're defining a function here, and then it takes in A, which is an integer, and it takes in B, which is also an integer, and then it's an arrow function. So it returns the sum of those two values. So A plus B is the return value of this function. So yeah, these ones are just like in Java. You have your type here, and then you have the name of the parameter itself, and then you have your type again, and then you can add as many as you want. And then you have the named ones. Now, named ones make it really, really easy. For example, let's say you're writing a really big function, or not really big, but a function that takes in a lot of that requires a lot of input to work. Then it will become really hard for someone who's going through the code to know which of those values are, like, what do those values basically mean. All right, let's say, for example, okay, I see here we call it, in this case we call our add, and then we pass in 2 or 3, but we don't know. Let's say we had a lot of these arguments being passed to the function. It will be hard to keep track of what those arguments are basically for. So with name parameters, we're able to tell what those arguments are for. So okay, again, we're defining a function. It has a return type, it has a name, and then it has the parenthesis, and then inside it you get the data it takes in, and then it's an arrow function, so it evaluates to this expression. So here you have required. Okay, this is an interesting one. So okay, we have an integer A and an integer B. That's what the function takes, but they are named inputs. So we cannot do something like this. All right, just want to show you this. So what Dart is complaining about here is that because all arguments that are named are basically optional. All right, so you can call a function without defining arguments that are without giving the arguments for name parameters, right? So what this is basically saying is that we're saying that A is optional, but we say it's an integer type. So if someone does not pass in A, we cannot convert, yeah, we're saying it's an integer type, but A is basically optional. So what we're supposed to do is basically say that A can be null, so that when someone does not pass in A, then its default value will be null, all right? Actually, I think this person puts it really nicely here. So what they're saying here is that if you don't put in required, then it's supposed to give a default value. If you don't put in a default value, then it's supposed to say that the type is nullable, all right? So this one, okay, I can't compare this feature to any other language. Python is something similar, but it's a little bit different. But yeah, so basically what this is saying is that you can name your, the arguments to your function. So yeah, and then we get the main function here. So in Dart, functions are first class. So what that basically means is that you can store them in variables. For example, our add function here, we're now creating a new variable. We call it our add, and then we assign the add function to it. So variables cannot only just be data; they can also be code. And this is what this what we're actually doing here. In C++, okay, not so many people said they know C++, but for anyone interested, in C++, you do this through function pointers. You will define a function pointer, our add, and then you point it to that add function. So in Dart, you just say, you define, our add as like a normal variable, and you just say its value is the function add. So what that basically means is that you can call our add as if you are calling add, because our add is basically add. Okay, that's a lot of adds. Okay, cool. So that's how that's what the first class thing you mean. So you can store functions inside variables. And secondly, you can pass functions to other functions. So this is quite an interesting line here. So we declare, or we define, there's no declaring in Dart. So we define a list. We're saying it has the items 1 and 2. And then for each item in that list, we want to print that item. So what we would have done, normally what we would have done is we will pass in a lambda, let's say our item, and then that lambda will call the print function, all right, to print that item. So that's what you would, or that's the first thing you would think about. But what you can also do is pass. So check this out. The lambda that we're defining here takes in one item, and then it calls print on that one item, or not on that one item. It calls print with that one item as an argument. So we can basically eliminate this extra code, this lambda here, and just pass print directly to the for each method of that list. So this is what you're doing here. And so you can pass functions to other functions. That's the whole point there. Don't get lost in the details. And then yeah, and you can define functions in any scope. Like you can define a function inside another function, and inside that function you can define more. You can define more functions, and you can define them basically in any scope. So if we run this, it's supposed to print our add 2 plus 3, which is 5. So that's what you're doing there, and then it prints this list, which is 1 and 2. So 1 and 2. Okay, so those are functions, and yeah, functions and the closures and stuff. So a closure is basically a closure. This is a closure. A closure is a function that exists in one scope but is passed to a function that exists in another scope. Yeah, that's the simplest way to put it. So that's what you basically, this is a closure that this lambda function we're taking here is a closure. It basically exists in this scope. What that basically means is that it can access the variables and functions defined in this scope to do its work. So yeah, okay, we're going way ahead of time. So those are functions, and then what I have now here are classes. So what I'm going to go through is the classes. So again, if I'm going too fast, just just say something in the chats, and just ask your questions if you have questions. Okay, I'm trying to paste in the new code. Okay, now we're going to be doing classes. So classes work, okay, they similar to the way classes work in Dart is kind of like similar to the way classes work in Java. So, you use the class keyword and then the name of the class, and then you have the body of the class, not really the body. Yeah, the body of the class. I don't know if that makes sense. Yeah, you use these braces to, define your classes stuff. So this is kind of like Java, and then you have a constructor, yeah? So this here is a constructor. Now I want you to watch how it does this. So let's start here. So we're saying this class has the member variable name, all right? But watch how we have the underscore before name. So this underscore means that it's telling the compiler that this name is private, all right? So string underscore name is telling the compiler that this name is private. So in Java, you will do the same thing as in like private string name. But in Dart, you don't need the private. Or I think to make the language a little bit simpler, they decided to remove the private and just something private, you add an underscore before the name. Yeah, before the name, you just add an underscore. So this underscore name underscore person are private string member variables, all right? And then here we have a constructor. So what we're saying here, again, to remember, Dart is optimized for user interfaces, like to describe user interfaces. So you want code that is as clean as possible, all right? You want things to be done in the cleanest way, yeah, like the cleanest way you can get. And that's what, they did here. So let's say here, this is a constructor that takes in a name and the surname, but then at the same time, it sets the given name to, it sets the member variable name to the input name. Okay, let me just write another one just to show you what this basically is saying. So let's say we have person. Okay, I'm just going to disable this one because it's going to complain. In Java, you will do something like this, all right? You will say person, and then you'll say string name, and then say string person, not person, surname, I mean. And then you will have your, the body, and then you will say this dot underscore name is equal to name. This dot underscore surname is equal to surname. So what this, okay, it's complaining about the this. It's saying it's unnecessary. Let's just remove it. But in Java, okay, yeah. So this is what you would kind of like write in Java, right? Something in these lines. In Dart, it's still valid. I don't know why it's complaining. Okay, yeah, it's a little bit different. So what you would write something like this in Java. So where you take in the the inputs, and then you set the member variables to those inputs. So in Dart, there's a shorthand for that, and this is basically that shorthand. All right. You say this first input is going to the name, and the second input is going to the surname. So this is kind of like the constructor. Obviously, you can still have your body here, and then you do your other stuff here. I don't know what you want to do depending on your how you write your application. So it's basically the same thing, and you can still take in more inputs. Let's say, for example, you want to take in age, you can do something like in these lines. So yeah, that's how you can write your constructors. And then here, just like in Java, you can override. So Java, every object in Java, or every class in Java extends the object interface, or implements the object. It extends the object abstract class. All right, it extends object. Yeah. So in Dart, you have the same thing. Person, there is an object. Object class. For example, object D. Just like in Java, you have object like this thing would exist. So in Dart, it also exists. And object has a toString member function. So what that's supposed to do is basically print or basically convert that class to a string. And how you convert it is all up to you, all right, as a developer. So in this case, we have a person class, and to convert it to a string, we basically put the name first, and then you put the surname. Again, this is string interpolation. You have the name, and then you put a space, and then you have the surname. And yeah, and then you can also have getters. So a getter is kind of like a getter is a function that returns a value, all right? So in Java, I'm using Java a lot because a lot of people say they know Java. So just to make things a little bit easier. So in Java, you have something like string get name, all right? And then here you will return name. This is what you would kind of like do in Java. And it still works here as well. So string get name, return name. In Dart, so how you would call this, you would say, for example, let's say here, you will say person.getName, and then it will return the value that name.getName returns. So in Java, you have the same thing, but you don't need to show, or you can show it as like it's not really shown as a function. It's kind of like, it acts as like a value. It acts like a value, all right? So string get name is a function that returns name. It's an arrow function, as you can see here, that returns the value of underscore name. So that's what you're basically doing here. Where is it? Let's say, for example, here dot name. So this here will call this function over here, or this getter over here. All right. How you define the getter is again all up to you. For example, you can do something like this, and then you do other work. I don't know what you want to do. You do all your other work, and then you return, the final value. Let's say, for example, before, let's say you want to do, the work you want to do is maybe convert the name to, maybe to capitalize the name, to make it, to uppercase. Yeah, to convert it to uppercase. And you would do your work there, and then you return the, the name. And how the person will exit, or the other developers, how they will access it, they will just say dot name, and they will be calling your getter. All right. And then here, you basically have the same thing here for surname. And then you also have setters. Again, in Java, you will do something in these lines to set like a private field to something. For example, set name, and then you have string name, and then you will say this dot name. Okay, I'm typing to it first. And then here you will say underscore name is equal to name. So this is the kind of code you will write in Java. So in Dart, it's the same thing, but you're now treating it as like a variable. All right, like you're treating it as like you're not calling a function. I don't know if I put these things right. Yeah, you're just treating it like a variable. So it's the same thing. It basically takes in a string, like the new name. So set name is a function, is a getter rather, that takes in a new name, and it takes that name and it assigns it to the name member variable here. All right, and we do the same thing for surname. So yeah, we do the same thing for surname here. And then obviously, just like Java, you can have your public method, you can have your methods, I mean. So remember that if your method starts with an underscore, it's private, all right? So for example, this one is public, and the minute I set it private, it's gonna say nothing is calling it because there's no other code in this class that's calling private member variable. So, and because outside users cannot call this private method, it's going to complain that, let me see, where is it saying it? It's going to complain that it is not accessed. There we go. The declaration underscore method one is in reference. So yeah, if anything inside a class that starts with an underscore, not really anything, member variables and member functions that start with an underscore are private, and those that don't are public. So that's how simple it is, all right? Obviously, these are just like normal functions as we like saw. The return value, the name, then the parentheses, and then the body here. So yeah, then obviously you have the main function. So what we're doing here, we're creating a new person object, and we're passing in the first passing in the name. So it's going to set the name to Batandwa, and then it's going to set the surname to my surname here, Mgutsi, and then we print the person. So what's happening here is the way they, the interesting thing is, so let's run this first. So print person is going to call, so what that does, or what print does, it calls the toString. When you print a class, a custom class or anything, it calls the toString method in that class, and then it prints that value, the value returned by that class. So here, when you say print person, you're basically calling this method here. All right, we're calling this method here, which basically puts my name first, which basically puts the name first, and then the surname, which is what we get in here. All right, and then here we're calling the setter this set name. We're saying person.name is equal to SpongeBob. So how it looks is that it's like you have a member, like this class has a member variable called name, and we are assigning SpongeBob to that name. But what we're actually doing, because it's defined as a setter, we're calling a function called name. All right, we're calling a function called name, which takes in a string, which is this one we're passing here, and then it takes the string and it assigns it to the name member variable. So this is what you're doing here. We're calling a function, not setting a variable, even though that function does set that variable. All right. And person.surname is equal to square pants. It's basically the same thing. And then we say print person.name, we're calling the getter now, which is this one. So the setter is always called when you say dot something is equal to, and when that dot something is a setter. And when the getter is called when you say, when you're trying to retrieve that, that variable rather. Yeah. So what you're doing here is calling the name getter, which returns SpongeBob, which is what we're getting here. Okay, cool. Again, if you have any questions, just pop them in the chats. We were supposed to finish, but we're taking our time. Okay, I see someone has to leave. Cool. So glad that you enjoyed it, Nabil. We're basically almost done. Actually, this is the last one. This is the last construct I'm gonna discuss, because after that there's another exercise. But again, we can't do the exercises because time is going. So I'm just gonna. So right now I want to show you generics. Now, for those who have seen Flutter, if you haven't checked out Flutter yet, don't be worried about this. It's going to make sense, as we go on. So if you have seen Flutter, you would have noticed a lot of code like this. Class my widget extends stateful widget, and then you will have your, let's say it's I don't know, let's say doubles. The state is the doubles, not doubles, is a double, is of type double, and then you implement your stuff here. So if you've checked out Flutter, you'd have seen something like this. So what we're going to be discussing here is this part. What does this mean? So actually, yeah, it's the same as in Java. Java has generics, all right? So what that basically means is that you allow the user of the class to determine the type of certain certain members of the class, all right? So here we have a class called data store, and it has this generic variable. Actually, I don't know what you call those. Okay, so we have this class called data store, and it has this item member variable, and this item is of type T. So what you're saying, yeah, is that we're telling the compiler that we don't know what the type of item is going to be, but we expect the user of this class to tell us. All right. So this is what generics mean. So when you do that Flutter code like this, the stateful widget class so stateful widget is basically a class that maintains the state of, it's a widget that maintains state, but it doesn't know what kind of state you want to maintain. All right. So, in some cases you want to maintain a list of people, right? In some cases you want to maintain a list of people. And in some cases you will just want to maintain, for example, just an integer or some arbitrary type, my custom class. So stateful widget is basically saying, yeah, it doesn't know the type you want to maintain or you want to keep in it, all right? And yeah, you have to tell it which type you want to keep. And this is how it's kind of like defined. You have the class, and then you have this these angle brackets, and then you have the types that the user has to give. All right, you can obviously have more than one type. For example, TS, TS. You can have like you can have as many types you want the user to give as you want. And then obviously you can have something like S, another item here. So what you're basically saying here is that we don't know. So you're saying that we have a class with the member variables item and another item, but we didn't know the type for those items, all right? We want the user to tell us what's the type for those items. So that's what generics basically do. And yeah, it's the same as in Java. So again, this data store class is basically saying here, this class has a member variable called item, but we don't know, or the class or the developer of this class, or the programmer, the writer, does not know what the user might want to store, or the data type the user might want to store in this class. So they let the user decide. So if we check again here, we have the constructor, and this constructor takes an item, and it basically sets the internal item value to this value. So if we get to the main function, we're using this data store clause. So we're saying variable list of doubles, and then, okay, this is a list of doubles, just a normal list. Again, here, lists are also generic classes, all right? Lists are also generic classes in that you can store any type you want inside a list. But in this case, we're telling the list class or the list implementation that we want to store doubles in this list, all right? So this will be a list of doubles. I want to check if I hover over it. There we go. It's a list of double values because we told it that in that list, we want to store doubles. So that's what you're doing here. And then here we have, again, here we're defining basically a map. So a map, so this map maps Bob to 45. We can maybe say that's the age, I don't know. So what this map is saying, or these angle brackets here, so they're saying we have a map, but the key will be string and the value will be double. So if the programmer tries to add something else, let's say they try to set a key that is not a string, or they try to set a value that is not a double, we want the compiler to complain, because all keys must be strings and all values must be doubles. That's what the developers of this, that's what we want. That's what we're telling the map implementation, that we want keys to be strings and values to be doubles. Now here we're using our own class that we define to be a generic class. So here we're saying that we have a data store class, and the value that it keeps is an integer, all right? So we're telling the compiler here that, okay, so we want to use data store, and we want the type of item to be an integer. And that's basically what we're doing here. And it's a final one, so we cannot say, because it's final, we cannot later say, for example, is equal to another data store. It's going to complain because it's a final variable. We cannot, does it say something there? Yeah, there we go. So the final variable store of int values can only be set once. So if it's final, you only set it once, all right? If you want to define a variable that you can set multiple times, don't use final. If you're sure you're gonna, set it once, then just use final. And then here's another interesting case. Here we're allowing the compiler to infer the type that we want item to be. So here we explicitly told the compiler that the type is an integer, right? But here we're telling it that we're gonna pass you a value, and from that value you want to infer the type that you can use for t. And because this is an integer, the 45 is an integer, then this data store is basically the same as the first data store. In fact, when we hover above, there we go, above this thing here, you can see that data store is an integer. So the hint, not really hint, the int type was inferred from 45. Let's say, for example, we were to say string hello world, all right? This is supposed to change to, let's check the type, data store string. So this data string is the same as, if we would have done something like this. It's the same thing, but in this case, when you remove that, we're saying infer the type from what we give you, all right? So yeah, that's generics. Yeah, that's just another feature Dart has. It's exactly the same as in Java. Yeah, exactly the same actually. So if you know Java, you already know this. And that was basically all that I wanted to cover. Yeah, I think that's all you will need, to get started with Flutter, like in 2 weeks' time when we start digging deeper into, the framework itself. So yeah, that's all that I think you will need. So if you just go over what we covered the structure of a Hello World program, the comments, we have documentation comments, we also have single line comments, and we have multi-line comments, I mean. We covered that, and then we also covered how to import your libraries, and how to use import aliases, and yeah. We also covered variables and types, integer variables. You also have doubles, you also have numbers, you also have booleans, all right? We covered that, and we also covered list and maps. We then went on, okay, see, we skipped something actually, but we can do that now. It's really quick. And then we went on to cover functions, especially lambdas and closures. So closures are what you would call in Java lambdas. And yeah, we covered that. So functions are first class, so you can store them in variables, you can pass them to other functions, and you can define them in any scope. So yeah, that's just another good feature. Again, especially when you write applications that pull data from databases, you will do a lot of mapping, like taking your list and then mapping those variables to something else. So those lambdas and closures basically come in there, passing one function to another function. Yeah, we then covered classes, but I see we forgot to cover the like inheritance, yeah. And then we covered the what do you call this, generic classes. Okay, there's two things I see I skip, but I'm going to go through them really, really fast. Again, if there's anything that you think I'm missing, just say something in the chat. Then I'm just gonna run through it, or anything you don't get. So, okay, the control flow constructs basically. So this is exactly the same as in Java, everything except for the for each loop. Java does not have a for each loop, or it does, but it looks a little bit different. I think in Dart you have for, and then you have the column there. Yeah, I'm not really sure, but it's a bit different. So if, and then you have the Boolean expression here, and then you do your work here. So that's the if statement, and then you have an if else statement. You do something, you pass in a Boolean expression. If it's true, something is done here, and if it's false, something is done here. And then you have a for loop, which is the same as in Java, C++, and not sure about C#. Yeah, but it's the same as in Java and C++. You have a variable x, and we assign it the value 0, which basically means it's an integer. Yes. So the type is inferred from the fact that we assigned it 0. And then we say x is less than 5, and then x++. So just as you would do, in Java when you're running through a list, for example. And then here we have a for each loop. So a for each loop is like for how you can read it, like how I find it. You can say for each x in this collection. So for each x, for variable in this collection. Or you can say something like, if it makes the reading a little bit easier, you can say item. It basically goes like for each item in this collection. So here we're saying for each, let me basically change this to item. So here we're saying for each item in this list, so this is a list containing 2, 4, 6, 2, 4, and 6. So for each item in that list, we want to print that item. That's supposed to work. Let's see. Okay. We don't print this because 3 is not equal to 4. 4 is equal to 4, so we print nothing here, which is basically what we have here. And then we come to the loop and we print 0, 0, 1, 2 to 5, to 4 actually. So because it said less than 5, so 0 to 4, and then 2, 4, 6 is what we're printing here. For each item in 2, 4, 6, print the item. And then here we have a while loop, which a while loop is basically just like in Java, you have it runs as long as this expression is true. So here we're saying 3 is not equal to 3, which is basically false, so it never runs. Wait, 3 is not equal to 3, so it's false, it never runs. And then here we have a do while loop. I don't know if there's supposed to be that thing there. Again, it's just the same, it's just like in Java. You have your do, and then you do the initial stuff here, and if from that computation you did here, something is not satisfied, you then run again. So do something while something is true, basically. So do something while something is true. So that's the control flow stuff. Now, just want to do inheritance really quick, like really quick. I'm really sorry about the time, people. I am really sorry. I miscalculated everything. Okay, so here again, remember we had that person class. We had class person. So this code we've already gone through. Class person takes in the name, and it takes in the surname, and then we have this other extra stuff like the getters and the setters, and then the methods. Now here, this here is a derived class, is a class derived from person. So again, it's the same as in Java and C. Okay, no, in C++, no. C++ is a little bit weird because there you will do something like public, which is a little bit harder to read. This basically means extends. I don't know why they did that. But in Java, you have something like this, and it's the same as in Dart. So class employee extends person, and employee has an employee ID. Because it extends person, it also has the name, the underscore name, the underscore surname, and all this stuff. And again, we have this, okay, check this out. So how we pass in data to a superclass or to the base class, we call super, and then, so this is calling the constructor basically, the constructor of the base class. All right, so the base class is person, and then we're calling that constructor here. So employee has an employee ID, and then we take in the name, we take in the surname, and then we set the employee ID to the last value that is passed to the constructor. And then you have this colon here. This formatting kind of like sets it off. So you have a colon there, and then you call the constructor of the superclass, which is the person class. And then obviously you can do your work here, whatever you want to do. Maybe you want to verify that, the data you're getting is correct. What most people do, in Dart and Flutter when they write their own classes is that in the constructor, they don't do any work other than assigning, like member variables, I mean. So in here, you don't write any business logic kind of work, like verifying if variables are correct or not. You basically assigning your member variables to something. So that's what most people do. And I think that's kind of like clean. Again, remember, you want to write code that can be read by other people. And the last thing you want is writing something that someone will come back to you and say, hey man, what are you doing here? Or hey person, what are you doing here? Whatever kind of thing. So you want to keep everything clean. So what most people do here is just assign, their member variables, or initialize their member variables rather. Like from, from the given ones. So and then we override the toString method. So remember in the person class, we override the toString method defined in the object class, which person extends, all right? it doesn't show there that person extends object. But person extends object, just like in Java. And then we override the toString method here for person, right? And then now person extends employee, and then again we override the toString method. So what this method is basically doing here is the toString method defined in the parent class, which is person, and then it adds this extra string at the end of the toString method, at the end of the value returned by the the toString method in parent. So this super the toString is calling this here. And then you say plus, and then you put the colon, and then we add the employee ID, which is the new data we got, which basically is supposed to print the name, the surname, and then colon, and then employee ID. So let's just check that out. So void main, create an employee, new employee, we give them a name, a surname, and then we set the employee ID. So name, surname, and we set the employee. Okay, cool. So when you call print employee, it's going to call this method here. So this method calls the super, and super.toString prints this part, or returns this part, the name and the surname. And then this method just adds the last part, the colon, the space, and then the employee ID. Okay, and you see people are running. And yeah, that's basically all. Again, I'm really sorry, about the time. I actually wanted us to go through an example of a HTTP request. An HTTP request, I mean. I don't know if we actually have time for that. But I will share my what do you call this? My code with you, with the exercises that you can actually try yourself, and just go to the stuff. Again, if you run into anything, or not really anything, if you run into any issue or you struggle with something, just pop it in the group. I will be there, and other people who know Dart will assist you. So yeah, that's basically, yeah, that's the end of this session we have. I see someone is saying tomorrow there's no session. Okay, that I'm not sure about, but I will check. I will check with the other people, like the other club members, if like the team, if there's anything happening tomorrow. I'm not sure. Severe, I'm not sure if he's still here. Yeah, but we'll let you know. All right, cool. Again, I really wanted us to go through this example. Let me see if it really opens. For those who have time. Okay, if you have any questions, you can just pop them in here. Then I can answer them. But that's basically the end of our session. Yeah, and we will have our next session for mobile development in about 2 weeks time, I think. Yeah, the week after next week, because next week is basically web. Yeah, next week is web, and then the week after next week is mobile again, and then we will keep going like that. So the next session, or in the next session rather, we'll be going through Flutter, the details and everything, and writing our applications, and then going on from there. So yeah, if you have any questions now, you can pop them in there, and I'll still be here. So for those who are staying, I'm just going to go through the HTTP thingy just to show you some of the things that we have learned, like how you would basically in a real world application. So I'm trying to open it, and for some reason it doesn't open. I'm going to open a new pad. Let me open HTTP. There we go. Okay, this code like this, you will see a lot on the, so like how some people, like as you will see in the next few weeks, you will see how people will divide their code into the user interface, then they will have the business logic, and then they will have their services or the API wrappers. So on the services and API wrappers side, you will see, code like this, code that communicates with the backends, databases and everything like that. So if you run through this, this is the working Dart program. if we run through this, okay, let me just explain what it does. So this uses the Google API to search for books about HTTP. All right, so the query here is HTTP, and it returns the number of books returned, or it prints the number of books returned by the API. So print number of books about HTTP here. Okay, so in the first line, we importing the convert library. It's part of Dart. So that library contains classes to, what does the description say? Yeah, it contains classes to encode and decode JSON, like JSON strings. And it also contains code to, encode and decode UTF-8, the select strings, from bytes to bytes. And yeah, oh, it's only those two, JSON and UTF-8. Okay, that's interesting. So that's what's defined in the convert library. And then here we import the HTTP package. So see how this one is saying Dart and then :convert. So this is part of the Dart library. So this is part of Dart, right? It comes with Dart itself. And then package is downloaded from, let me show you where. So in Python, you have something like, in Python, you have pip, like pip3, pip2, yeah, whatever you use. In Dart, you have pub.dev. Yeah, pub.dev. So that's where Dart packages are, that's where people who make Dart packages push their code so that other people can use it. And that's what you're doing here. We're saying we want the package HTTP, and from that we want to import it as HTTP. So we're importing the HTTP package, and basically we're importing this HTTP file from the HTTP package, right? So http.dart as HTTP. Again, this is an alias. These are aliases. Convert as convert, and then http.dart as HTTP. All right. And okay, so if we check HTTP here, we're supposed to see the package. There we go. This is the package that we calling, or that we're requesting from, for our application. Now we have our main function, and the main function takes some command line arguments, and it's async. We didn't go through this, but when we get to Flutter, we can go to this. And then you have the single line comment, another single line comment. Then you have a final variable called URL, which is basically built from a URI. So this URI class has a static method or a factory method called. We didn't go through factory methods, but again, we still got Flutter to go to that. So this URI method has a factory method. Let me just see. Okay. Yeah, there's a factory method called HTTPS, and what that does, it takes in all these segments and it puts them together to form a URL. And then we call the response, or we call the HTTP package, we call get in the HTTP package to basically to get the data in this URL. And then that response will be in JSON. So this response, okay, this is the response object. So we get the data from this URL, and then obviously if the response status is 200, then we know that everything was pulled or was downloaded, like the data was pulled, like the data is good, we pulled everything successfully. And then we take the JSON response. So we get the JSON response from the response body. So this response body is a string, all right? It's a JSON string. And then we call convert.json decode. So convert is basically okay, this JSON decode is a function inside the convert package, right? So when we say convert.json decode, we're calling a function inside the convert package or library. So yeah, library rather. And yeah, so that convert function, not convert function, the JSON decode function is basically taking the string response body, and then it returns like a JSON response. And the JSON response is dynamic, so that because because, okay, JSON objects can be like maps and lists. Yeah, those are the two objects that, this method can return. So it returning dynamic, it can be basically shows that it doesn't return only lists or only maps. It can return a map or it can return a list. So that's why this type is dynamic, all right? And item count, yeah. So here, okay, so in this case, the JSON response is a map, all right? So what you're doing basically here, we have the total. So in that map, we have a key, and the name of that key is total items, and then we basically getting the total items in that map. And then we print the number of books about HTTP, which is printing those that item count or the total items from that map. And then if the response status is not 200, then we assume that everything failed. So this is just like if you run that, you're supposed to get the value, like the number of books. So yeah, this is kind of like similar to Java, like the syntax and everything is just like Java, I mean, except that a lot of things are, are made easier. So yes, people, yeah, again, I'm really sorry about the time. Yeah, that's really it from my side. I think the team is going to send something just to get some feedback from you guys, like how you found the thingy, like what would you like to be improved next time. Obviously the timing is something really serious. So yeah, that's really it from my side. So if you have any questions, just pop them in here. Otherwise, have a good evening. I'm going to share the notes I have with the code in the group as well as in the emails. So yeah, so don't worry about that. I'm going to share everything. Oh, thank you, Moses. Thanks a lot. I was, like when I got here, I was a little bit nervous, like, first time presenting, to like teaching people about something like this. Like I've made a lot of videos before, but getting to this level, kind of like my first time. So yeah, thanks a lot. If you guys enjoyed this session, yeah, obviously your feedback would be really appreciated. But I think again, the team will send something, like a form maybe that you can just fill out, just to give some feedback. Otherwise, thanks a lot, guys. This was a really great session. Even though I couldn't, like you guys couldn't, say anything, it was still great. Okay, I'm gonna end the meeting now. I don't see any questions. Yeah, bye. Okay, yeah. All right, bye, guys. Again, have a really great evening. We will talk some other time. Hopefully next time, I would have found my way around this thing, like this platform. Cheers, cheers.